Hello everyone, welcome to CIVIL FLEXURE. This is Sasikuma. In this video, we will discuss analysis of indeterminate beam using compatibility method. Right? देखिए क्या होता है कि जो indeterminate beam होता है just like propped cantilever, continuous beam and fixed beam, ठीक है? तो उसको एनालाइज करना काफ़ी डिफिकल्ट होता है without knowing the matrix method and all. Okay, so in this video, with the help of this compatibility method, I will show you that how you can be able to calculate the support reaction of any propped cantilever beam or any continuous beam. Okay, so before starting the video, please subscribe my YouTube channel and press the bell icon for latest update. So let's start. So I am taking here one example, and with that example I will show you that how I will be able to calculate the support rate. Right? Suppose that I have one propped cantilever beam, right? Suppose like this integer roller support, this is integer fixed support, and this beam is loaded with one UDL having intensity of W, right? I am naming here it is a support A and it is a support B. So how can we able to calculate here support reaction 1, suppose that vertical reaction VA and here's vertical reaction VB. So since it is a fixed support, so here reaction will be generated one horizontal also and one moment is also generating here, right? So how will we calculate these four reactions? So if we able to see the degree of static indeterminacy in this, the degree of static indeterminacy for the beam, that is ds, is equal to r minus 3. So r is how much here? One horizontal reaction is here H, one vertical reaction, one moment, that is 1, 2, 3, and one vertical reaction at support B. So reaction is number of reaction is here 3, and available number of equilibrium equation to solve the beam or any structure, that is 3, that is here 3. So here degree of static indeterminacy, here we are getting 1, sorry it should be 1, right? So we can say this propped cantilever beam is a indeterminate beam with degree of static indeterminacy 1, right? So how many number of additional reaction, additional compatibility condition we have to generate over here, that is 1, right? Means हमको यहाँ पे एक compatibility condition generate करने का जरूरत पड़ेगा, right? Here you can correct it, compatibility स्पेलिंग, राइट? तो हम लोग को यहाँ पे क्या करना है, एक compatibility condition generate करना है. So let's see how can we generate the one compatibility condition, right? So if we want to convert or break this beam into two parts, so how can we generate, right? So this beam equals to, we can write one simply cantilever beam, something like this, with loaded UDL W and plus one cantilever beam with the reaction, this is VB, right? So we can write this beam is equal to combination of these two beams, right? One cantilever with loaded UDL and one cantilever with sustained reaction VB. So since this support is here one roller support, so net deflection over here, this at point B, we can say that 0, means delta B equal at B, right? Sorry, it's delta at B equals to 0. Why? Here it is a support reaction. So due to of this UDL load, the total deflection due to of this deflection due to this reaction, we can say the combination of these two reaction deflection will be 0, means delta due to of UDL load plus delta due to of vertical reaction VB. It can be 0, right? Because at this support, the support one roller support is active. So I am telling you, when a cantilever beam loaded with UDL, so net deflection over here, so this will go a certain like this. Something deflection curve, it will show something like this. So it will be the delta of UDL, and due to of this vertical reaction it will deflect something like this. So this deflection will be delta due to the vertical reaction VB. So combination of these two will be 0. So I am telling you one important thing, you should remember this thing, that when a cantilever beam loaded with UDL, so net deflection at the free end, means at this point, will be how much? It will be equals to the, I am writing here, WL to the power 4 upon 8 EI. So this is the standard case, or with the help of slope and deflection method. There are various methods of calculating the slopes and deflection, right? Like conjugate beam method, Maclaurin's method, double integration method. You can be able to calculate, right? So you should remember this thing. So this now plus, and another thing you have to remember, that when a cantilever beam loaded with a point load at the free end, then deflection at the free end is how much? I am writing here VB into L cube by 8 EI, right? Oh sorry, it should be 3I, writing it here once again, right? So it should be how much? VB into L cube upon 3 EI, right, equals to 0. So one thing you should remember, this deflection is going downward and this deflection is going upward. So I am writing here one with minus sign, right? Minus sign, right? So now this is the, you can say, compatibility condition. So when we evaluate this equation, we will get WL to the power 4 by 8 EI equals to VB into L to power cube by 3 EI. So LQ and L to the power 4 will go on. Here EI will go on. So from here what we will get, VB equals to 3 times WL by 8, right? So this is the support reaction at B, right, at this point. Clear? Now once we will be able to calculate this VB, then what will happen? We will be able to calculate rest reactions. Suppose like this. My beam was something like this. Right. So I am removing this support. Right. And in place of this support, I am putting one vertical reaction VB equals to 3W by 8, right? So now the support reaction is known, this loading intensity W is known. So with the help of equilibrium equation, that is summation of Fy equals to 0, means sum of all vertical reaction equals to 0. So if here vertical reaction VA and VB, so we can write VA plus VB equals to W times L if L is the length of the beam. Okay, so VB we have calculated, so VA equals to W times L minus VB. VB will come in this side, so 3W by L, 3WL by 8. So from here VA will get 5W by L by 8, right? VA we get, and now since all the loads are vertical loading, so horizontal reaction H will be 0. So one moment will be generated over here. So we can calculate the summation of moment, right, at B equals to 0. So what we get? We got this one moment reaction 1 M, right, moment reaction I'm taking clockwise moment as a positive, minus W into L by 2 equals to 0. So from here the moment M will get WL square by 2. Sorry, I will get another moment, this will not come, right. We will get another moment over here due to this VA, right. This VA will get our clockwise moment, means VA times L, and after putting VA equal to 5W by L by 8, we get here M equals to WL square by 8. Clear? So this is the method that how we'll be able to calculate the support reaction using compatibility method of any indeterminate beam. I am taking another example here that are very important, that are, this was the one cantilever beam. Now I am taking one example of continuous beam, right. So let's take example here. Suppose that I have one beam, continuous beam with two spin. This is suppose that roller support, another this is the roller support, and this is over here is pin support or hinge support. And this beam is completely loaded with UDL with intensity W. Suppose that this support is A, this support is B, and this support is B, and the length is over here, that are L, that are, right. So I have to calculate the support reaction at A, at B, and at C. So how we will be able to calculate using compatibility method, right. So let's break this beam into two parts. So how can we able to break this beam into two parts? Suppose that this is the total length here, sorry, pin support over here, one UDL was acting, and one roller support was present over here. So if at A one vertical reaction VA, at B vertical reaction VB, at C vertical reaction VC was generated, and here one horizontal reaction. So this horizontal reaction will be 0 because all the loadings are here the vertical. So I am not considering this into my calculation. I am showing here this is the point A and this is the point C, and I am replacing this VB as V P, right? So now this one is equal to this, and now this beam I am dividing into two parts. So let's see how. Here pin support, UDL load was acting, roller support plus here pin support, here roller support, right? One vertical reaction VB, and this is the support A, this is the support B, support A, and this is the support. So this beam we can be able to write like this, and since joint B is one roller support, so at this point B, can we say that delta at B point equals to 0, means net deflection equals to 0, right? So how can we write? Let's see over here. So delta due to of UDL minus delta due to of VB, and we write equals to 0. So because of this UDL, the beam will deflect something like this, and due to of this point load, any point vertical reaction, this beam will deflect like this. So this deflection and this net deflection, if we will add, then we will get the deflection 0. So another thing you have to write, remember over here that when in a simply supported beam, one UDL is acting with of intensity W, then net deflection is WL to the power 4 by EI times 5 by 384, right? Minus. Second thing that you have to remember over here is when a point load at the center is acting in a simply supported beam, then net deflection is WL to the power WL to the power cube by 48 EI, right? So here you can say, right, the VB into L cube by 48 EI equals to 0. Why I have taken negative? Since this deflection is at downward and this deflection is upward, right? So this deflection I have taken negative and this deflection I have taken positive. So net deflection will be 0. So from here, when we will write 5 by 384 into WL to the power 4 EI, right, equals to VB times L cube upon 48 EI, L cube to the power 4 gone, EI gone. From here we will be able to calculate VB, and that will be equals to the 5 by 8 times WL, right? So once similarly we, just like the previous case, we will be able to calculate support reaction VA and support reaction at VC, it should be C, with the help of by adding sum of vertical forces equal to 0 and sum of net moment equal to 0. So this equation will not required, it will be required to calculate one of the reaction, because when we will write the summation of Fy equals to 0, two variable will come, one is VB and VC. So one is we will get from summation of M equals to 0, and after that one either VC or VB we will be able to calculate, and we will put in this equation, then we will get both the equation, right? I am not showing here over here that how much it will come. So I'm just writing the value that how much it will come, right? So just you calculate. So when you will take summation of Fy when you will take summation of Fy, then you will get one reaction equation, something like 2 times Ra plus 5 Wl by 8 equals to Wl, right? And when we will take summation of M about B equals to 0, from here we will get the MB equation. So the moment at B point equals to minus WL square by 32, and Ra you will get 3WL by 16, right? Clear? And due to symmetry, the Ra will be equals to R at C, right? This will come how? Due to of symmetry, right? Due to symmetry, it will what happen? Ra equals to Rc. Clear? So I am showing all the things here once. That what we have done. We have taken one beam, right? Continuous beam that are to a span. We are dividing into two and taking the compatibility condition that net deflection at point B equal to 0 and writing the deflection amount, and with the help of deflection amount we will be able to calculate VB, and once VB will be able to calculate, then with the help of summation of Fy equals to 0 and net summation of M equals to 0 we will be able to calculate VA and VC, right?